All right, 6-3, we're going to talk about conditions of parallelograms. So, did you hear about the quadrilateral who wanted to be a parallelogram?
Why, yes, his opposite angles weren't quite up to par.
They don't get any better, you guys. So anyway, continuing on. You guys just talked about your properties for parallelograms. And your properties said if it's a parallelogram, then this happens. If it's a parallelogram, then this happens, yada, yada, yada. In this case, when we talk about our conditions, we're talking about something kind of sort of opposite. If you notice, these are our conditions here. A quadrilateral is a parallelogram if any one of these is true. So if you have both pairs of opposite sides parallel, well, that's going to be a parallelogram. If opposite sides are congruent, it's going to be a parallelogram. If opposite angles are congruent, a parallelogram. Remember, this is angles, you guys. If consecutive angles are supplementary, parallelogram. If diagonals bisect each other, parallelogram. So all of these were our properties. So if you see these in a picture, you can guarantee that this is going to be a parallelogram. The only one that's different and extra is number 6. Number 6 says that if you only have one pair of opposite sides, parallel and congruent, then it's going to be a parallelogram. So you only need one pair of those sides, but then they have to have both things, being parallel and being congruent. Then it's going to be a parallelogram. So if you take a look at this first example, I'm going to ask you to determine if this quadrilateral is a parallelogram. You have to justify your answer. Well, if you take a look, number 1, obviously, yes, this is a parallelogram. The reason why, well, if you take a look at number 2 from your notes, the ones that we just did, those conditions, we have both pairs of opposite sides congruent. So you would write yes. Both pairs of your opposite sides, are congruent. Okay? Number 2, is this a parallelogram, yes or no? Well, if you take a look, having these angles congruent means that these alternate interior angles are congruent, leaving these sides to be parallel. Well, if they're parallel and they're congruent to each other, we should know that, yes, this is a parallelogram because we have one pair of opposite sides, parallel and congruent. So one pair of opposite sides are parallel and congruent. Okay, number 3, let's see, I've got a pair of parallel sides and then a pair of congruent sides. Well, remember, the only one that we have that deals with both of these is number 6, when it says one pair is parallel and congruent. So this does not satisfy any of them. This would be a no. And number 4, remember, you need consecutive angles to be supplementary. This is a dead giveaway that, no, this adds to equal 170 degrees. We need 180 degrees, so that's going to be a no. Okay, so show that JKLM is a parallelogram if A is 3 and B is 9. Well, what's going to happen is you're going to go ahead, number 1, and use your information for, let's say, A or B, either one. I'm going to look at the side A since alphabetically A comes first. A, remember, is 3. So let's take a look here. If A is 3, I have 15 times A minus 11. And let's see if that equals 10 times A plus 4. Now remember, A, you guys, is 3, so I'm going to plug 3 in. Over here, we end up with 45 minus 11. Over here, we end up with 30 plus 4. Well, does 34 equal 34? We sure do. So we have one pair congruent. Okay, now, the only other one that this could satisfy is if it had two pairs congruent, so let's check the other side as well. So I have 5b plus 6, and it's got to equal 8b minus 21. Remember, b, you guys, is 9, so 5 times 9 and 8 times 9. What happens is we end up with 45 plus 6 equaling 72 minus 21. Well, does 51 equal 51? It sure does. So yes, we have both pairs of opposite sides congruent, so there, ooh, that's awful, sorry guys. So therefore this has to be a parallelogram. Okay, using our conditions, I would like for you to show me that PQRS is a parallelogram if x is 10 and y is 6.5. Pause me, figure out which condition will work, and then we're going to go through this. All right, so going over your conditions, the one that you should have noticed fit our picture, looking at these angles, is that our consecutive angles will have to be supplementary. Well, in order to test that, we'll have to see if QR add to equal 180, and then if RS add to equal 180. If this happens, then we know that it's a parallelogram. So please check to make sure that our consecutive angles are supplementary. Okay, so when we plug in our values for X and for Y, you should notice as you work it through, going from Q to R, we are supplementary. The second one, R to S, we are supplementary. So your answer should be that PQRS is a parallelogram because, what is it? Consecutive angles are supplementary. All right, last one, determine if the quadrilateral is a parallelogram and justify your answer. I'm going to let you do this, then we're going to come back and talk about this. Okay, so one way people have figured this out is to solve for this angle. We know if it's a four-sided figure, these should add to equal 360. So if I take x plus 107 plus 73 plus 107 equals 360, you find out that x is 73. Okay, knowing that x is 73 shows that both pairs of opposite angles are going to be congruent. So there is your parallelogram. The other way that people do this is looking at consecutive angles. Well, if your consecutive angles are supplementary, in this case those are, and these are, they add to equal 180, this is also a parallelogram. So justifying your answer would have depended on which way you used. You could have either had both pairs of opposite angles congruent, or you could have had your consecutive angles supplementary.